This is a class project for wireless communication. My name is Wenling, and the class project name is Application of Ultra-Wideband to Indoor Localization. Indoor localization is very popular these years due to the development of Internet of Things, and we will have more and more smart equipment in the future that needs localization. A commonly used localization system is Wi-Fi. The advantage of Wi-Fi is it is very easy to implement, and there are many existing hotspots that can used. The disadvantage of Wi-Fi is the precision is very low. So another approach comes out using the ultra-wideband signal. The ultra-wideband signal is narrow pulse with short duration. It has high transmission speed and low transmission power. The localization system using ultra-wideband system is very precise. Here are three different types of UWB localization algorithms. The first one is received signal strength indicator based. The second is angle of arrival based. The third is time based. The time-based method was used in this project. Time-based method computes the time of flight to compute the distance. There are also two ways to compute the time of flight. One is clock synchronization. The clocks are synchronized in the whole system and just record the transmitting time and receiving time will know the time of flight. But clock synchronization is not usually implemented for the indoor localization. So another way is to compute two-way ranging or round-trip time. The signal travels from transmitter to receiver and back and forth, so just record two receiving time will get the time of flight. This picture shows how time-based UWB localization system worked. After knowing the distance between each anchor points to the object, we can get the location of the object. 2D localization needs 3 anchor points to compute the location, while 3D localization needs 4 anchor points. The main problem for the time-based UWB localization is non-line of sight problem. Non-line of sight problem is basically the signal from the object is attenuated by the obstacles in the room, thus can affect the arrival time and has an error in the localization. There are two methods introduced to solve this problem. One is NLOS classification with convolutional neural network. The input signals from all anchor points are classified as NLOS and LOS signals. If the signal of the anchor point is classified as NLOS signal, it is eliminated from all the anchor points, and the other signals are fed to the localization algorithm to compute the location. Another method is ranging error mitigation using convolutional neural network. For each anchor point, the neural network is trained to compute the error and weights. The error is subtracted from the results, and weights are used in the localization estimation. Here are two localization algorithms. The first one is least square algorithm. This algorithm uses pure Euclidean distance to compute the location of the object. Another algorithm is weighted least square, WLS algorithm. In this algorithm, a weight is used to mitigate the error for different anchor points. Using weight matrix W, the estimated ranging error for each anchor point can be mitigated, and the weights for a closer anchor point can be increased. The weight is trained from the error mitigation regression. The architecture of the convolutional neural network is shown in this figure. First, the input are fed to two convolutional layers. The convolutional layers use Adam optimizer to optimize the gradient descent. Then, the output of the convolutional layers are fed to max pooling layer. Max pooling layer downsample the features. Then there are two more convolutional layers and another max pooling layer. And then there is a fully connected layer, a dropout layer, and at last a readout layer. This is the model code. In the convolutional layer, the weights are randomly initialized and the bias is constant. The input is preprocessed to 256 batch size and the activation function is ReLU. The pooling layer was max pooling with size of 2. Then the class entropy is calculated with softmax, and the Adam optimizer is used in the gradient descent. The architecture of ranging error mitigation is barely the same as an LOS classification, so I don't show it here. This is the training process. The training process for the NLOS and LOS classification takes about 10 minutes, and the results show the true positive, true negative, false positive, and false negative classification results. The accuracy of the classification is 88%, and the precision is 86%. For ranging error mitigation, the training process takes about 2.5 hours. This program computes the weights and saved as a weight matrix. The error is computed for all possible locations. The overall error, mean error, minimum error, and maximum error are also displayed as a result. This is the evaluation of NLOS classification system using CNN. Another two machine learning algorithms are used to classify the signals to compare the performance of the system. Two types of support vector machines, SVM, and multi-layer perceptron, MLP, are implemented. Accuracy, precision, sensitivity, and F1 score are calculated based on the classification results. We can see the accuracy of CNN is 5% higher than the other, and F1 score is 3% higher than the others. This indicates CNN has a better performance in NLOS classification than the other machine learning algorithms. This is a evaluation for the different localization methods. The first table is least square algorithm using only LOS signals. The error is very small. The second table is the least square algorithm with raw data. We can see the error is very large because the NLOS signals. The third method is least square algorithm with NLOS classification. We can see the result in this method is very close to the first one. The last table shows the weighted least square algorithm with ranging error mitigation. We can see this method performs very good. The mean error is even smaller than the first result. So in summary, weighted least square algorithm with ranging error mitigation using CNN has best performance, but it took a lot of time to train the model. The least square algorithm with NLOS classification using CNN also has a good performance, and it takes less time to be trained. In this project, machine learning algorithms were used to solve communication problems. I think machine learning has a great potential in the future to solve many problems in different areas. Thanks for watching.